Study about electric field due to a dipole. There are two cases. In first case, electric field due to an electric dipole at points on the axial line. If the point is situated on the axial line of the electric dipole, then we can calculate the electric field intensity due to the electric dipole as follows. Consider an electric dipole placed on the x-axis and a point C which is located at a distance of r from the midpoint of the dipole along the axial line. Small r is the distance of the point C from the midpoint of the electric dipole, and here P is representing the electric dipole moment of the electric dipole. The electric field at point C due to positive charge is given by E plus is equal to 1 upon 4 pi epsilon naught into Q upon R minus A whole square along BC. Here R minus A is the distance of the point C from the positive charge Q. Since the electric dipole moment vector P is from minus Q to plus Q and is directed along BC, the above equation can be rewritten as E plus is equal to 1 upon 4 pi epsilon naught Q upon R minus A whole square P cap. And here P cap is the electric dipole moment unit vector from minus Q to plus Q. The electric field at point C due to minus Q charge is given by E minus is equal to minus 1 upon 4 pi epsilon naught into Q upon R plus A whole square P cap. Here R plus A is the distance of the point C from the negative charge. Since positive charge Q is located closer to the point C than minus Q, so E plus is stronger than E minus. It is also clear from the equations for E plus and E minus. So therefore the length of the E plus vector is drawn larger than that of E minus vector. The total electric field at point C is calculated using the superposition principle of the electric field. Apply the superposition principle to find the total electric field. We get E total is equals to E plus plus E minus, and it is equal to 1 upon 4 pi epsilon naught Q upon R minus A whole square P cap minus 1 upon 4 pi epsilon naught Q upon R plus A whole square P cap. And finally we get E total is equals to Q upon 4 pi epsilon naught into 1 upon R minus A whole square minus 1 upon R plus A whole square P cap. On solving the equation, we get E total is equal to 1 upon 4 pi epsilon naught into Q into 4 RA divided by R square minus A square whole square P cap. Note that the total electric field is along E plus. Since positive charge Q is closer to C, point C, than minus Q. And so in the diagram, the E total representing the total electric field due to electric dipole at point C. If the point C is very far away from the dipole, then we can write R is greater than A. Under this limit, the term R square minus A square whole square is approximately equal to R power 4, and we can write it E total is equals to 1 upon 4 pi epsilon naught 4 AQ divided by R cube P cap. And here we know that the electric dipole moment is equal to twice aq p cap. So E total is equal to 1 upon 4 pi epsilon naught 2p upon r cube. So if the point C is chosen on the left side of the dipole, the total electric field is still in the direction of pk, in the direction of p vector. Now the second case, electric field due to an electric dipole at a point on the equatorial line. Let us consider a point C at a distance r from the midpoint O of the dipole on the equatorial plane, and it is clear from the diagram that the distance of the positive charge from point C is equal to the distance of the point from the negative charge. Since the point C is equidistant from the positive and negative charges, so the magnitude of the electric fields of the positive and negative charges are the same. The direction of E plus is along BC and the direction of E minus is along CA. It is clear in the diagram that the direction of E plus is along BC and the direction of E minus is along CA. E plus and E minus are resolved into two components, one component parallel to the dipole axis and the other perpendicular to it. So the perpendicular components E plus modulus E plus sin theta and modulus E minus sin theta are oppositely directed and cancel each other, and the horizontal components E plus cos theta and E minus cos theta are in the same direction. It is clear from the diagram, and the magnitude of the total electric field at point C is the sum of the parallel components of the E plus and E minus, and its direction is along minus p cap. E total is equal to minus modulus of E plus cos theta p cap minus modulus E minus cos theta p cap. The magnitudes E plus and E minus are the same, and magnitude of the E plus and E minus is given by E plus modulus E plus is equal to modulus E minus is equal to 1 upon 4 pi epsilon naught q upon r square plus a square equals to minus 1 upon 4 pi epsilon naught twice q cos theta upon r square plus a square p cap. Here cos theta is equal to a upon under root r square plus a square. E total is equal to minus 1 upon 4 pi epsilon naught p divided by r square plus a square. Or at a very large distances we can write r is greater than a, and E total is equal to minus 1 upon 4 pi epsilon naught p upon r cube. At very large distances, the magnitude of the electric field at point on the dipole axis is twice the magnitude of the electric field at points on the equatorial plane. The direction of the electric field at point on the dipole axis is directed along the direction of the dipole moment p, dipole moment vector p, but at points on the equatorial plane it is directed opposite to the dipole moment vector, that is along minus p.